Tim Griffin will give the next presentation on desktop infrastructure in a multi-screen world. Tim Griffin is a CTO of Userful Corporation, a leading desktop virtualization software company. Tim's vision for a simpler, more cost-effective way to deploy centrally managed desktops has been the driving force behind Userful's line of virtualization products and the 1 million desktops deployed worldwide.
Hi, I'm Tim Griffin, CTO of Userful. Thanks for your time today. Today we're talking about desktop infrastructure in the post-PC multi-screen world. And I think it's a very exciting time to be involved in this area of solving the IT infrastructure challenges. There's a real openness out there now to new approaches brought on by this shift to new operating systems like Android and iOS that really, this openness hasn't existed since Windows rose to dominance over 25 years ago. So, you know, there's lots of challenges out there today, and there's lots more just around the corner, and it's a very exciting time to be involved in this particular area. So I thought for today, what we'd talk, you know, obviously we're talking about business after Windows and what that means for infrastructure. But I thought we'd start by taking a big picture look at some macro trends, and then delve into some of the problems people are facing today and will likely be facing in the future. And then compare and contrast some of the different infrastructure solutions that are on the market today, some of the more popular ones. And then spend a little bit of time dissecting this as a service, blank as a service trend, and that model and where the opportunities for real value are in that model. And looking forward to sharing some of these thoughts today. So let's talk about the macro context. I mean, right now we kind of have a foot in a bunch of different worlds, right? So one foot still in the PC world, you know, and Microsoft did a great job of putting, a PC on every desk, right? And along with that came that personal file store that's also on every desk. And then Apple, of course, did a great job of putting a touch screen in everyone's pocket. And then, you know, Google and Dropbox and other companies like that have done a great job of giving us this anywhere, any device file access. And if you're like me and like most organizations, you're probably living in these three worlds. You know, you've got some PCs with some files on them, some files and a cloud storage, and some smartphones in your organization as well. And we're kind of straddling all these three worlds. I think it's important when you're thinking about infrastructure to also think about, okay, well, where are we heading? What's the future going to hold? And our contention is that there's going to be even more and more screens, many, many times more than there are today. And you know, obviously with this move towards the Internet of Things, you know, I would say these screens could be viewed as the visual or interactive side of that Internet of Things, the window into the Internet of Things, these many, many screens around us. And so, you know, today there's a screen on your desk and one in your pocket, but tomorrow we'll likely have an interactive screen in every room, in every public space, in place of every printed sign, in the back of every seat, in every retail store shelf. There'll be many screens. In every appliance, there'll likely be some screens. At every point of service, you'll likely have screens instead of people. And, you know, obviously at checkout till today, you see this, but you'll see even more of it. You know, probably in place of every mirror there'll be a screen, and possibly in place of every clock, and probably in place of every point of control. So there's this trajectory. If you think back about how many screens you had in your life 10 years ago versus how many you have today, you'll see this trend and this massive growth in the number of screens. And you know, this obviously begs the question, how are we going to power and drive all these screens and control them and create the kind of experiences that people actually paying for those screens want to provide? And so we're moving from a one PC per person model to dozens of screens per person, and that creates some pretty big challenges. Obviously, there's the model that we have today of a PC under the desk or a PC running in a data center is we've got this aging, insecure traditional desktop PC, and industry stats are sort of the TCO of a managed Windows PC is somewhere between $1,000 and $7,000 per PC per year. And obviously, that's not going to scale up to the type of situation that we were talking about earlier in terms of the screens all over us. Desktops, I think it's also worth understanding that, it used to be that IT departments spent all of their time managing desktop computers, and that was their focus. Now desktops are just a small part of their job, maybe even less than 10% of their job in some situations. IT departments are doing a whole lot of different things. And so we need something easier than what we have today in terms of managing that infrastructure. And users also are demanding the flexibility to use different operating systems, different applications, and and that can be a key part of attracting key talent, is offering that flexibility. So clearly, it isn't going to be a traditional OS and architecture that powers the multi-screen post-PC world, right? It's not going to be the kind of thing that we've grown up with, where you have a dedicated piece of hardware that's containing files and users, and you boot it and you log in and you shut it down. So new approaches are needed, and thankfully there are some very exciting ones coming. And let's talk a little bit more about that. So if we're going to understand the infrastructure for the post-PC era, I think we have to have sort of a shared understanding of what exactly the post-PC era means. So here's a few things we can certainly all agree on. I think that almost no one wants a 20-pound metal box under their desk creating a huge amount of noise and heat and collecting dust. And I think we can also agree that while the small portable screens that we put in our pockets are very handy, they're certainly not for everything. And all of us who've tried to do real work on a small screen have run up against these frustrations. And I think once we agree that portable screens aren't for everything, I think we can also agree that our non-portable screens should be as large, plentiful as possible, and also sustainable. So what do we mean by that? Well, sustainable means that there's a reasonable environmental footprint in terms of not needing to be replaced too frequently. So you don't want to put a screen out there that lasts for 3 or 4 years. Obviously, with a cell phone, it's pretty easy to replace your cell phone. You simply buy a new one and power it on and put it in your pocket and transfer your settings. But if you've got a screen that's say 40 feet in the air at an airport, replacing that screen or replacing the device that powers that screen is a very substantial investment. You've got to hire the unionized contractor to make a truck roll, come in, climb up on a ladder, and make that happen. So infrastructure is very different than personal devices, corporate infrastructure, in terms of the cost of maintenance and replacement. So we want screens and devices behind them that can last for 7, 8, 10 years, basically the lifespan of that display. So let's examine some of the leading options. Obviously, there's embedded PCs, Byod, Chrome OS, traditional VDI, and Appliance Vdi. And we'll talk about each of these in detail and just go through them. These are in terms of the options that are available today, the interesting and exciting ones for providing infrastructure in this post-PC era. So we'll start off with the embedded PC. So the idea here is that you take the traditional PC architecture but build it into a display. So this is, some people call it an all-in-one, obviously this works well in a mobile environment. May not work so well in an infrastructure environment. This eliminates the cable clutter, but it doesn't really solve the IT maintenance burden and security challenges of having these standalone PCs out there. So, and then obviously from a sustainability perspective, you need to throw out the display every time you want to upgrade your PC. So if you need to upgrade your computing power every 3 years, but a display might last for 5 or 12 years, you're off cycle there. And then one of the other key problems with embedded PCs is they really have the same problems as a traditional PC. Obviously, you've got a very high cost of management and maintenance, and in theory, a PC individual isolated running PC offers flexibility, but realistically, when it's managed in a fleet, even a small change becomes cripplingly expensive. So take, for example, I'm sure we've all experienced this, where you go to the IT department and say, look, I'd like to have this change, and they say, well, no, that's not possible for, until the next golden image gets rolled out. And that's quite common to have this kind of inflexibility in IT because of the high cost of change with this fleet management. And obviously the PC architecture requires constant vigilance on security, and that comes with the territory of having large numbers of standalone devices. And I think what's also worth noting is that the power costs alone of standalone PC, which consume a huge amount of power, you can pay for a replacement zero-client device if you're moving to a different type of architecture, like, for example, a VDI or thin-client architecture. So next, let's talk a little bit about BYOD as a way of sort of providing infrastructure for the multi-screen world. And obviously, this is about leveraging personally owned consumer-grade devices for work. And in a business setting, at least today, the potential benefit is largely to do with increasing staff productivity outside the office. Obviously offering a platform choice to your staff can be a morale boost. So there'll be some people who really want to work on iOS or really want to work on Android all day, and enabling them to do that can be a real morale boost for those particular employees. But I think it's worth remembering that some people like the idea of BYOD based on the concept that the organization doesn't need to own any infrastructure. I think it's important to realize that physical computing devices are really a rounding error in the labor costs of most organizations. And so, while BYOD probably works well in a virtual organization where everyone's working from home, but in a more standard office environment, there's really high risks in sort of transition to this. Obviously, there's the risk of data loss if people are working on documents that may not end up back in the company's possession. And then there's also, strong potential for reduced productivity during work hours, and that can easily and quickly offset any potential cost savings you might have had on the devices. And I think there's also an awful lot of complexity in managing devices in a BYOD environment, and those problems haven't really been solved fully yet. And so, BYOD, it makes sense for some organizations, depending on the way that organization is structured. And what the perceived productivity impact of the decision is. I think there's also some really exciting things going on with Chrome OS. Obviously Chrome OS has achieved remarkable cost savings. It's a free operating system, but offers a very constrained environment. So here it's the browser-only environment, and this is great for organizations who can do everything in the browser and who are comfortable in trusting all their data to Google. And I think it would be great also for startup organizations who haven't yet, incurred any of the training costs or of using applications that may or may not be compatible with that browser environment. So yeah, I think we can all agree that browser applications are likely, either the future or a strong portion of the future. But switching cold turkey from native apps to browser apps is not always the most efficient or popular way to achieve organizational change. So moving, say, from a Windows infrastructure today to Chrome OS infrastructure, sort of moving from 100% Windows today to 100% Chrome OS is more change than organizations can really digest in one sitting. And some kind of gradual transition plan to the cloud makes more sense from an infrastructure perspective. So one of the often brought up infrastructure opportunities is VDI, and I will talk about it here as traditional VDI. So this offers many benefits over traditional PCs. Obviously, it eliminates the hardware headache of having physical data stores distributed throughout the organization and physical PCs to maintain throughout the organization. And it allows you to move to thin clients instead of fat PCs. That has a lot better security, better remote access, better centralized control. But one of the things that's been a problem is that traditional VDI has very high upfront costs and complexity. So it's not unheard of for people to spend as much as 2 weeks getting a pilot up off the ground of VDI. And you need a highly skilled IT team. There's an awful lot of factors to consider, and it all needs to be sized in advance, and it's very data center dependent. And then there's also, despite all these high costs, there's often performance limitations and things that just really do not work well in a VDI environment. So because of that, VDI is sort of limited in terms of the numbers of different use cases it can support, both from a cost perspective and also from the performance perspective. So traditional VDI offers security and long-term advantages, but the high costs and complexity have really limited uptake to those large organizations and the early adopters who have a really strong business case for VDI. I think it's worth also pointing out that VDI has really been encumbered by the punitive VDA licensing costs from Microsoft. So it costs far more from a Microsoft licensing perspective to go VDA than it does to buy the same number of Windows PCs, for example, in terms of the Microsoft licensing costs. So and obviously complex data center architectures as well. So, our contention is that in terms of infrastructure, traditional VDI isn't really useful for what we call the early majority or the late majority, and also for smaller organizations like small businesses and SMB. So, a little bit more on VDI. And the limits of it in the post-PC world. So, almost the entire VDI industry runs the full instances of Windows today. So if you look at Citrix or VMware, their focus is really about running a full virtual machine for Windows. So this is basically taking the PC out from under your desk and running it virtually in the data center. Now, obviously, there's some management tools to help make that more efficient, but architecturally, that's what's going on. And while this eliminates some of the physical challenges of PCs, the architecture is still inefficient and expensive. And so it's an isolated instance of Windows with a user who has files and applications, and then you've got this $100 per seat per year VDA tax from Microsoft. And I think we can all agree that spinning up a full Windows virtual machine, so a remote employee can sort of struggle to securely edit a Word document from their tiny iPhone screen, is probably not the best idea our industry has ever come up with. And the limitations of performance have also been a key barrier to applications of things like multimedia, call centers, digital signage, etc., where really latency and multimedia performance are key. So one of the other limits of VDI in the post-PC world is we've got these two trends going on, right? On the one hand, we've got companies like Google and Dropbox sort of saying, hey, look, you don't need to, there's other ways to securely share access and collaborate on documents and allow you to edit documents on any device. And that's really challenging the whole need for running virtual machines. And so there may be other ways of controlling document access that don't require running a full virtual machine. And so, I mean, I think that what the IT industry is realizing is that we need a simpler, lighter, faster, centralized desktop solution that's architected for the challenges and opportunities of the post-PC world. And one of the ways of achieving that is what we like to call Appliance Vdi, right? And so this is a much lighter, much simpler, much faster way to get going with virtualization. And it's built on Linux and open source technologies. The price and performance lends itself to a broad range of use cases. So, unlike VDI, which you typically are spending $1,200 per desktop once you factor in all the hardware and software and licensing, this is under $200 per desktop in terms of all of the hardware, software, and licensing. It offers a choice of operating systems at every terminal, and you're only incurring the licensing and CPU cost of Windows when Windows is required. So there's lighter ways, such as Chrome, lightweight Chrome browser containers and lightweight signage sessions of delivering the functionality you need at certain types of endpoints without spinning up a full Windows virtual machine. So this local appliance approach leverages the low-cost x86 hardware, as you do with many organizations today, and eliminates the need for a data center. So you've got, on the one, at the endpoint, you've got an ultra-secure device. It's a zero client, very, very inexpensive, and lasts for 7 to 10 years. And you can, as I mentioned before, have a complete VDI solution, including the device, the server software, the server hardware, and the support for as little as $199 per seat. And then you also have the centralized management from the browser. So it efficiently runs a mix of Chrome, Windows, Linux, and allows people, it gives your end users the flexibility to choose the environment that they work most comfortably in. So, it's easy, obviously, to get started for small deployments by simply buying one of these appliances, and it's very quick and easy to scale by buying more of the appliances. So, if you can fit 10 users on 10 or 20 users on a Core i7 PC, you buy several of them, and you have 40, 60, 80 users. So a little bit about Userful. We do interactive screen infrastructure designed for the post-PC world. We have 1 million seats deployed today in over 100 countries, and covering a really broad range of use cases. We have call centers, digital signage, a lot of schools, a fair number of libraries, some military, some hospitals, some like any horizontal technology, it's used in a whole bunch of different areas. It's an efficient and flexible way to deliver intelligent screens as infrastructure. And what that means is obviously centrally powered with basically what's essentially a graphics card and a USB hub at the endpoint. And that makes it basically the thinnest possible endpoint you can imagine. A graphics card and a USB hub attached over the network to your central server. And so that's why these thin clients perform so well, and it's also the reason why they have much lower cost than traditional thin clients. And then on the server side, what Userful has done is implemented what we call just enough virtualization, so an extremely high-powered, lightweight server software that delivers, we call it containers that are highly optimized for the use case involved. So if somebody needs a full virtual machine, they get it. But if somebody just needs a browser, they get a very lightweight browser session. And this allows us to deliver, blazing multimedia performance and very low latency, and makes it great for applications like call centers where a traditional VDI has really struggled. So this Userful software installs on any x86-64 hardware, whether it be a PC or server class hardware, and it's all managed through a browser-based drag-and-drop GUI. So basically, you quickly create these containers. You can create a container in a couple of seconds, and then you can map them to any endpoint just by dragging and dropping those endpoints into the containers. And then Userful also has an optional cloud management add-on. So what does this mean? VDI that is designed for the post-PC era. So VDI products can be costly, time-consuming, and intimidating for customers that aren't really ready to adopt the full set of features and benefits. And this is a way to get going with VDI that doesn't require that heavy lifting at the beginning and heavy expense too. So everyone likes the idea of centralized high-performance desktops, but a lot of people are still sticking with PCs because of the high expense of and the the complexity of going to VDI, and also full VDI is overkill for many of the computing needs out there. And I think it's also worth understanding that in this post-PC and in the post-Windows world and post-PC world, there's many types of desktops out there that people want to use other than full virtual machines. So a lot of people, all they need is a browser. Some others, they need to, do a sort of lightweight cloud session of sorts. And some people need an RDP or a Citrix session, and some people just need a full virtual machine or a Linux desktop or an Android desktop. And you want to have a VDI solution that gives that kind of flexibility. So basically, multi-platform, useful multi-platform makes it simple and easy to do VDI, cloud clients, thin clients, terminal emulation, digital signage, touch kiosks, etc., all from that central server model. And we also work with some of our hardware partners to do these power over Ethernet display options. And the exciting thing about this is you can basically put a display anywhere without requiring a power outlet. All you need is an Ethernet Cat5 Cat5e run. So basically, this is great if you're trying to put, for example, screens in the middle of store shelves, and you don't want to, pull a bunch of electrical permits from the city and hire an electrician to come in at midnight to set it up. Right? You can have your IT department run the power over Ethernet cables and plug in your displays, whether they be touch screens, power over Ethernet touch screens, or whether they be keyboard and mouse and screen stations. So that basically allows you to put a screen almost anywhere with a very, very low cost in terms of the infrastructure costs. And it also allows people to transition to the cloud without having to give up Windows cold turkey. We talked about that earlier. People are looking to experiment with browser-only desktops, but still want to keep one foot still, at least in the short term. And some users may be comfortable with Windows. This allows them to do both at the same time. This appliance is very useful in a variety of different. This appliance model is very useful in a variety of different situations. Obviously, there's large-scale connectivity projects. Useful actually holds a world record in this area with over, for the world's largest VDI deployment, over 500,000 virtual desktops into the Ministry of Education in Brazil. And then, obviously there's digital signage and video walls and kiosks, and we'll talk a little bit about the video walls later on because that's a very exciting application for this appliance model. And there's this sort of the traditional virtualized Linux and browser desktops and containers, and then obviously interactive touchscreen infrastructure. We've talked about that too. So one of the exciting applications that sort of showcases the performance of this type of architecture is Useful's latest offering, which is a 4K network video wall. What that basically allows you to do is connect up to 25 different screens, 1080p screens, to a single Core i7 PC, and you can run perfectly synchronized video on all 25 screens. And so this is a very exciting demonstration of the multimedia performance of this technology in comparison with traditional VDI. Basically, you can run multiple 4K video walls from a single PC, and that gives you an idea of the high performance and video throughput, and eliminates many of the traditional expenses associated with video walls. It also allows you to use video walls, for interactive applications as well as sort of more public display and signage applications. So I think now that we've sort of got a feel for the performance, I think it's worth explaining why these appliance VDI and Useful in particular is able to achieve this type of blazing performance. And I think it really comes down to the architectural differences between the Useful approach and a traditional thin client. And so this diagram helps illustrate that. So really with a traditional thin client, let's say you've plugged in a webcam into the USB port, right? And I'll just try and illustrate it here. So basically, let's say you plugged in the webcam to your USB port. That webcam takes a picture, and it's processed by the local operating system, right? And then it's encoded into a protocol, and then sent out over the network to the server, which then decodes it from the protocol, right? And then it's processed by the local operating system on the server, and then it's encoded again into a protocol, sent back out over the network, then it's decoded by the thin client again, and then finally it's output to the display, right? And then if you compare that with the zero client architecture, you plug in your webcam, it takes a picture, it gets sent over the network to the operating system on the server. The server does its work, processes that picture, and then it outputs directly to the display adapter. So this is the difference. I mean, a thin client is really a mini PC, and it functions just like a PC. And it's talking back and forth with the server, encoding and decoding every single pixel into a protocol that's designed for use over the wide area network. With the usable zero client approach, basically we have it's like having those devices directly connected to the server in terms of basically we're using the network to enable communication between the graphics card and the server operating system, and between the USB bus and the server operating system. And it's just much more efficient in terms of graphics performance. And that's how you can get things like this 4K network video wall with 25 screens from a single PC. So let's talk a little bit about some of the macro trends here. So obviously there's dramatic growth in the numbers of endpoints, including really high growth rates in VDI, thin clients, and cloud clients. And then there's also strong growth in alternative endpoints like touchscreens, signage, kiosks, commercial displays, and smart TVs. And as we were saying earlier, the web-based apps combined with this diversity of devices in the ecosystem has really created an openness to new approaches at the endpoint, and particularly for we'll call it desktop infrastructure that we haven't seen in the last 25 years. And so increasingly organizations are looking at new models for providing and maintaining their screen infrastructure, where some or all of the solution is provided in the way of something like a complete out-of-box solution provided by a trusted vendor. So let's go a little bit more into this trend, and we call it blank as a service, right? Or some of it's desktops as a service or infrastructure as a service. But we'll look at the various approaches and try and understand the different value propositions. And I find that sometimes an analogy is the best way to make this clear. So we'll borrow an analogy here from Albert Barron, who sort of had this idea of using pizza as a service to sort of describe the differences. And here we're going to talk more about the pizza as a service as a way of figuring out the value proposition. So obviously, you can build your own pizza from scratch, buying all the ingredients, making it all yourself, buying all the infrastructure, and that's going to be, perhaps your most expensive approach. Then you could also get the frozen pizza approach, where you keep a sort of a freezer full of different pizzas. You pull one out whenever you're hungry, stick it in the oven, and obviously that's extremely efficient on cost and on time. Then obviously you can get delivery, right? A little bit more expensive in terms of cost, roughly the same amount of time to call up the pizza, answer the door, pay the guy, unbox it, etc. And then you can also, go even further to the extreme where you're eating out, which we, class as sort of a managed facility type of approach. And, obviously cost-sensitive organizations really need to operate in the middle, right? And that you're going to see extreme cost savings by staying in that area. Obviously the restaurant makes sense when service and atmosphere take a priority, and the do-it-yourself approach makes a lot of sense when you're willing to invest heavily to get that very special and unique pizza. But where this becomes more interesting is when we look at that layer on top of how people are doing desktops today. So today, almost everybody is doing their own in-house desktops, the equivalent of making their own pizza. And, that makes sense if what you're doing is truly unique on the desktop, but the reality is most organizations are not doing that. Most organizations have very predictable, repeatable needs that are very similar to other organizations in their space. And so it really makes sense for organizations to be looking at, this appliance model or a desktop as a service model. And in those models, you're either getting an appliance where you've got the operating system, applications, management tools, all provided as a bundle, and you're owning that appliance in terms of owning the server hardware, the endpoint device, and displays and mice, etc. Or a complete service model where you're sort of paying a monthly fee to get both the hardware and the software and the support. And Userful has two offerings in that area. Obviously, the multi-platform, which is what we've been talking about, installing on standard PC hardware. We also have a Userful desktop offering where you pay a monthly fee. And then obviously in the far right here, you've got more of a managed services type of a thing where you've got either an internet cafe or some kind of office facility where you just pay by the office or pay by the employee. So we've been through a lot of these advantages of the appliance. Obviously, we've got the for using just enough virtualization, where you can have a lightweight, highly efficient container session that is extremely efficient on the CPU and also on licensing. Then you can also have just enough thin clients. So using this sort of basically network-connected video card approach, which is basically 2 to 3 times the multimedia performance of a traditional thin client. Or other zero clients. And then you can also run any app or any OS. So while most VDI solutions are really geared towards delivering the Windows OS, Userful is engineered towards this post-PC era and lets you essentially deliver any OS or kiosk applications in a controlled and managed way. And the scalability, I think, is another key point. This appliance approach means you're not having to sort of decide in advance how many users you are and aren't going to have, as you do with traditional VDI in your data center. And so basically you buy more appliances as your needs grow and scale, and as new locations come online as well. And one of the other key things is it's for all types of screens. And I think we've seen that the future is not just going to be about computers on people's desks. There's going to be screens on the walls, in the store shelves, seat backs, etc. And this type of infrastructure allows you to scale up into the new types of screens as well. So thank you very much for your time and attention today. It would be a pleasure to speak with you or learn more about and what you're up to, and happy to answer any questions about either the topic or what we talked about today.